Good morning, students. Let us start our chapter Force and Laws of Motion and proceed to the topic Conservation of Momentum. Conservation of momentum states that the total momentum before collision is equal to total momentum after collision if no external applied force. Here you will get one new term, collision. What is collision? Collision is the interaction of two bodies for very short interval of time. For example, when we hit from a racket, the cock will strike the racket for few milliseconds. This is interaction, that is collision. So see student, I am showing you here. For collision, two bodies are required. So I have shown you, just see, before collision I have taken two body 1 and body 2. During collision they have interacted with each other, that means collide with each other, and after collision they have separated from each other. So for body 1, let us take a mass m1, initial velocity u1, final velocity v1. So its initial momentum will be before collision will be m1 u1 and final momentum before collision will be m1 v1. So change in momentum before collision m1 v1 minus m1 u1. So here this is for body 1. Let us take the for another body 2. For body 2, let the mass be m2, initial velocity be u2 and final velocity be v2. So for body 2, its initial momentum is m2 u2 and final momentum m2 v2. Here we have taken. So change in momentum will be m2 v2 minus m2 u2. Now as the body will collide, both the body will collide at the same time. So let the time be t. For time t, now we can write this one as rate of change in momentum during collision, that is before collision m1 v1 minus u1 by t, and rate of change of momentum, this is for after collision. We can write this one also as after collision m2 v2 minus u2 by t. Now from Newton's second law of motion we know that the rate of change in momentum is directly proportional to applied force. So let F1 and F2 are the force exerted by the body 1 and body 2 on each other respectively. So here what? F1 we can take m1 v1 minus u1 by t and f2 m2 v2 minus u2 by t. So by Newton's third law we know that to every action there is equal and opposite reaction. So F12 is equal, opposite, that is minus F21. So here in place of F12 and F21 we can write m1 v1 minus u1 by t is equal to minus m2 v2 minus u2 by t. So t is very short interval of time and at the same time both the body collides. So t and t will cancel. m1 v1 minus u1 and minus m2 v2 minus u2. So let us remove this bracket. We will get this one m1 v1 minus m1 u1 and this is minus m2 v2 plus m2 u2. Bring all the initial one left side and final one right side. So it will come left side. We can write minus m1 u1 minus m2 u2 and minus m2 v2 minus m1 v1. Minus you take as a common for both sides. We cut that minus. Both side it will cut it. So we will get m1 u1 plus m2 u2 is equal to m2 v2 and m1 v1. So what we have got it? Total momentum before collision is equal to total momentum after collision. Means total momentum is conserved when no force is applied. Okay.